Good morning, good afternoon, good evening, everyone, and welcome to Node's 2025. My name is Emil Eifrem. I'm one of the co-founders of Neo4j, and it's my absolute pleasure to be here with Dr. Andrew Ng, legendary pioneer of deep learning. Good to meet you, Andrew, and thanks for being here.
So to be here.
Fantastic. So we're going to cover a few topics today. I wanted to start with Agentic AI. So you coined the term Agentic AI, and it's obviously taking off. And I don't want to get caught up in definitional things, but just for the purpose of grounding ourselves in this conversation, like what is Agentic AI and how does it compare to other types of AI?
Yeah, I remember when I started to push the term Agentic AI is because there are a lot of people arguing what's an agent. And there are people that publish a paper saying, I built an agent. And others say, no, that's not really an agent. And I felt that if we just acknowledge that the degrees of autonomy or degrees of agenticness, then we can just say, is our agentic and get on with the more important work of building this. In the heart of Agentic AI is the idea that instead of zero-shot prompting or prompting a single time to do a work task, we can have a more iterative process of taking multiple steps of prompting, calling, and other things to stitch together these complex workflows. And within that space, there's tons of room for innovation. And I didn't expect that around last summer, a bunch of marketers would get a hold of this term agentic and slap us a sticker on everything in sight. But even though the hype for agentic AI has grown like that, the real business value has also grown, kind of really quickly. And I think a lot of the important work that lies ahead of us for the next decade will be to identify valuable workflows and implement them in agentic AI.
That makes sense. A few weeks ago, so early October, as we're recording this, you launched a new course on deep learning called, I think, just Agentic AI.
Agentic AI.
And it's a phenomenal course, by the way, for the entire Neo4j community. If you want to go to deeplearning.ai and sign up and go through it, it's really, really high quality. And
thank you.
In that course, you talk about 4 design patterns for Agentic AI: tool calling and planning, reflection, and multi-agent collaboration. Yeah. For those of you who have not yet gone through the course, do you want to just give a high-level overview of that?
Yeah, so the course Agentic AI, I try to share with anyone that already knows some things or getting started how to build effective agentic workflows for everything from customer service to building your own deep researcher to building some sort of healthcare or legal or whatever assistant to legal compliance. Our teams use these workflows for a lot of applications. So give you those set of knowledge. And beyond the 4 design patterns, which are important, also how to think about taking a complex business problem, say, or application, and decomposing that into smaller steps, implementing that workflow. And then also, if it doesn't work as well as you want, how do you drive a disciplined evals and error analysis process, which turns out to be super important in order to improve that agentic workflow. And maybe just to relate this to knowledge graphs, which I love and often use, I find that as a component of an agentic workflow, one reason that's often superior to just letting it read the text and say, have at it, is it allows you to have a specific representation of knowledge that's much more precise. And so sometimes when we do error analysis on some of our applications, we will say, you know what, the way we build that knowledge graph, the data is not clean. And let's just focus on cleaning out that data, looking at it, making sure it's correct. And this makes the downstream application much more reliable compared to we say, here's a bunch of text, let's do a fuzzy RAG thing and let the algorithm just read whatever it wants at the moment. That's actually sometimes harder to debug and harder to get to that, really good performance. But that's just one example of evals and error analysis, which is applicable to knowledge graphs as well as to many other components in agentic workflows.
Love that. And we're going to come back to knowledge graphs later on. But one of the questions, I observed that you did not use a framework in that course.
Yeah.
And we've seen a little bit of a pendulum swing in the Neo4j community where maybe a year ago, people used a lot of agentic frameworks or AI frameworks like the Lang chains and the haystacks and the llama indexes of the world, mostly for prototyping, I feel like. But I saw a lot of companies, when they put AI in production on top of Neo4j, they actually bypass frameworks. But in the last year or so, we've seen a surge of framework adoption back again with maybe it was easier when you had single pass, single tool, RAG, the way you did it 18 months ago, right? And now it's a little bit more complex. So we actually see more framework adoption right now. What do you see out there in the real world today in terms of frameworks versus going straight to models and databases?
It feels very diverse. So definitely Line Graph and Crew AI and a few others have real momentum. And from my friends that work on the frameworks, they're seeing rapid adoption. And then it's harder to get data on how many people are building, agentic workflows without frameworks. But anecdotally, that's also taking off rapidly. So it feels like there's some good building blocks, but you don't need to use them. And I think it's been, I personally sometimes use frameworks, but a lot of time do not, because, you can get a AI coder to just write what you want, even without a framework. But I find that for people getting started, some of the glue that the framework offers to pull together a lot of tools, for example, the number of integrations that some of the frameworks has done, that can be valuable. So I'm seeing really diverse ways of implementing this. So this is a good observation.
Yeah, and where is it going? Let's not try 5 years. That feels too long, but maybe call it 2-3 years from now. Do you see primarily applications written with frameworks or going direct?
I think both would grow significantly. There are some things we don't want to rebuild. So, I don't really want to have to build a new database myself. Let's use someone else's database software. Frameworks is one of the things. Sometimes there's a feature in, whatever. I use Langsmith for observability and it makes my life easier. But sometimes, it seems just as easy or even easier to just write it myself in raw Python.
Yeah, that makes sense. So I wanted to ask you about memory in agentic AI. So we see a lot of adoption of, startups building agentic memory layers on top of Neo4j. Folks like Zep or Cogni or Paper, actually out of Stanford. And I wanted to ask you how you think of agentic memory and what do you think of, is graph a good representation for that? Seems like many people are converging towards that, but I also live in the graph world. So obviously I'll see much more of that than other things.
Yeah, I wish I knew. Memory feels like one of the Wild West areas where there's a bunch of graphs, there's a bunch of extract raw text snippets and stick them somewhere. And then context engineering was a hot buzzword. I think actually one thing I often think about is I suspect that large parts of context engineering would be automatable, since that human context engineering, if you make a function call and it dumps a lot of context into history, maybe you don't want that. But the decision to compress that, compact that, lots of tokens from some function call, that's not a very high intelligence decision. It's kind of like, a little bit obvious you should do it. So because of that, I think there's a lot of room for automation of context engineering or context management as well. But I suspect that because the use cases are diverse, the selection of the downstream application often drives a lot of decisions for the memory. So if you need a very small amount of memory, having a bunch of, English sentences might be fine. If you need very high reliability, larger, a little bit of structure, I see a lot of use of graphs there. And then if you, kind of don't care or have the tokens that burn, then just stick everything in the context and then kind of run slower but easy to prototype that way and then clean up as you go along. So I'm seeing a lot of really diverse approaches to memory. I actually don't think it will converge because of the very huge diversity of downstream use cases and therefore the huge diversity of what we need to remember to serve that downstream. So I don't think we'll ever converge to one memory architecture.
That's super interesting. One of the areas that we're thinking very hard about right now and exploring is the interplay between, call it your RAG corpus and your memory state. On some level, both are state that your AI application can use. But my instinct is that there's a lot of value in being able to relate concepts from one state to the other, right? So let's say you have an internal project called Project Trinity, just as an example. You mentioned that in your Google Docs and in your PDF files. That gets entity extracted into Project Trinity. And then you have your conversational memory that is recording some conversations. And if we then mention Project Trinity, it should kind of know that it's the same thing we're talking about, right?
Yeah.
Does that make sense to you? And how do you think of that?
No, it does. I think for things where you use a graph database, it makes sense if you can have a sense of what are the entities or the relationships, and you have a lot of them. If you have an entity type where you have only one instance or only one thing as that entity, then, why is it a graph? But then on the flip side, we have a lot of unstructured data, which is a bunch of text that you can't format into a graph. And so I think because the nature of knowledge is diverse, I think the representations of knowledge will end up being diverse as well. So yeah, it'll be interesting to see how this evolves. The mix makes sense.
I want to switch a little bit to the future of agentic AI. So you have your 4 core patterns. As those mature and become much more established and well understood, what do you think is the next horizon after that? Do you have in your head another set of 4 patterns, for example, emerging?
No, so there's one exciting trend which sort of doesn't really work, but maybe it will someday, which is learning agents have much higher degrees of autonomy or much higher degrees of agency or agenticness. So, for example, a lot of the highly agentic coding systems, like be it Cloud Code or OpenAI Codex or Gemini CLI, you give a relatively high-level specification of a problem, it goes and figures out a lot of stuff by itself. This is in contrast to earlier generations of coding things where you gave much more scaffolding. Do this, then run a test, and then run this test. And now we give it a handful of function calls and then, kind of go figure it out. Or even the deep researchers, right? I built early deep researchers that are very structured. Do a web search, then fetch 5 pages, then summarize, and that was fine. But now you could actually let deep researchers say, here's some stuff, here's a web search API, have at it. And then it kind of figures it out. I think that outside of highly agentic coders and maybe a small number of applications where you kind of do less damage if you make the wrong web search call, this doesn't really work that well. So I don't see this used at all in production outside of those cases. But as we are implementing complex agentic workflows, I don't think it will lead to letting a system plan and do everything by itself. But I do see, even in the way AI Fund and Deep Learning AI, the way we build internal agentic workflows, the bites we let be more autonomous are gradually getting bigger. And so I find that exciting. And then slowly we end up, ripping away some of the scaffolding. We go, oh, I don't need to hard code the number of web search or whatever. Let's let it figure that out. So that's been very exciting.
That's awesome. It's staying with kind of the future of agentic systems. I think you've been on the record talking about the era of the one-size-fits-all model is over, or something akin to that.
I see, yeah.
And how do you think of, I guess you also believe, or at least we believe, that there's a multi-agent kind of future, right? And so is that kind of the state or the next couple of years, you think, where you have multiple agents all using their own kind of individual models? Is that how you see things evolving?
Yeah, so I think the reason we won't ever end up with one true LLM to rule them all is because the nature of intelligence is diverse. Sometimes you want to do spell checking with low intelligence tasks. Sometimes you want to plan and solve a really tricky map or coding problem, very high intelligence tasks, and then everything in between. So just like today, the nature of compute is diverse. Sometimes you have a tiny processor to control an LED light in your car. And sometimes you have the most powerful GPU you can get in a data center, or even a lot of them working together. So the nature of compute workloads is diverse, and the nature of what we need for compute is very different. And the nature of what we want from intelligence is very different. And so that means that we will have specialized models, specialized agents, rather than, one LLM to rule them all. Just like today, there's no such thing as one processor for everything. And it's the same for intelligence as compute.
That makes sense. Cool. I want to switch to talk about AI adoption in the enterprise. So I thought we could maybe try to reason by analogy, which is sometimes flawed. But you co-founded Google Brain early 2010s.
Mm-hmm. Yeah.
And this is something like that, right? And so this was the era, it's around the time of AlexNet, right?
Yeah.
And I guess the cat paper was post Google Brain, because you wrote it.
Oh, that was by Google Brain.
Yeah, exactly. That's what I'm saying.
Yeah,
so
yeah.
that must be
I see.
post.
Yes.
So around that era, can you just tell the audience a little bit, what did AI adoption, I guess we call it machine learning primarily back then,
see.
look like in the industry and at Google? And then how did you approach going from what you invented at Google Brain into getting that adopted in product lines at Google?
Yeah. So when started Google Brain, the controversial idea I had was that scaling up AI models would be a good idea. This idea that we could use a lot of compute, big data sets, train large models, and that would make progress. It's a controversial idea at the time. So, friends advised me, hey, Andrew, this is a bad career move. Don't do it. But fortunately, I did it anyway, and it worked out. And in fact, the early successes of Google Brain were inspiration. It was a model for other large companies to build up their own leading AI research divisions. And I had specific phone calls from a number of large companies saying, we saw what happened at Google. We need a lab like that too. And so that was interesting that it didn't just do good work, but proliferated this style of AI lab. Early days of Google Brain, I had to execute a change management exercise within Google to convince people to adopt modern AI, to adopt deep learning, because it's controversial. It was viewed as too black box of web search, too slow for online advertising, too much hand tuning, whatever, all sorts of things. But so it was very interesting that instead of working on advertising as my first project, my first major project was some research projects, but then also speech recognition, which was not really revenue generating that much for Google. But that let us have a success story, gain allies, put real things in production, serve users, and then keep on stepping up to bigger and bigger projects until, then we got to advertising eventually. And I think AI adoption today has a lot of parallels. One difference is everyone already has faith in AI because you read about the news. So that's easier, that you're convincing people that AI is an important thing. But the selection of projects and the sequencing still remains really difficult. So my friend Kirsty Tan and I at AI Aspire, we chat with large business a lot. And even though people see the potential for AI and believe in the potential, identifying the most strategically important projects for a business, whether top down or bottom up, that's still really difficult because it requires a deep understanding of the technology and then that strategic judgment to pick the projects that have a shot of transforming the business.
Yeah, so that makes a lot of sense. And it reminds me of what you wrote in the AI transformation playbook from landing.ai. Maybe you can just tell the audience a little bit about that line.
Yeah, so I wrote the AI transformation playbook before the rise of modern Gen AI, but it was about how to move organizations along to take advantage of AI. So everything there is still, I reread it recently, it still seems highly relevant. And it was lessons learned on doing the first few projects, which don't have to be too big. Hopefully they're successful with positive ROI, but it doesn't need to be the biggest win. But doing that quickly helps you then create successes to create even bigger successes and even bigger successes, as well as how to invest in the company-wide upskilling and training to then bring people along. So Kirsty Tan and I, AI Aspire, feel like transformation is ultimately done by people. Technology is exciting, but technology is, run by people. And so in some ways, as hard as the technology is always the easier part when it comes to corporations, is figuring out how to bring people with us. That's the harder thing. And so AI transformation playbook talks about that.
It's a really good read that I very much recommend for the folks, especially inside of big companies. So you talk about kind of technology.
And actually, recently I had an interesting experience. There's a friend in a big company that I won't name, a C-suite, and he called me up one day slightly annoyed at me because he said, "Darn it, Andrew, I've been telling my CEO this for 2 years. He wouldn't listen to me. And then, darn it, he finally read your thing. He's not doing it." So
there you go. So you talk about the people part of transformation, the technology part of transformation, and maybe I'll split the technology part of transformation into two pieces. One is kind of the systems and the software. The other one is the data. You've long been an advocate of data-centric AI, like a robust set of engineering practices for managing data. But when we talk to our big customers, the global 2000s in the world, they live in a very fragmented data landscape. And I don't know what you've seen work in terms of what are best practices in getting data AI ready for the enterprise.
Yeah, so maybe just share a secret that I think you know, but maybe not everyone does. Worked in large companies, very good AI brands. It turns out that all of us feel our data is fragmented and not good enough and too dirty, and it will never end. And I think the key is to start making progress on it, but not to spend 2 years rebuilding data to be AI ready. That actually doesn't work that well. It is instead identifying problems, identifying applications, and then building those applications and solving the data problems in a way that lets you build your applications. So let the applications pull your data infra forward. I think there's just a couple of general principles for data worth putting in place, such as accessibility, maybe thinking about how to break data silos. Well, I think the overall data architecture is worth a little bit of effort, but once you've kind of put those architectural principles in place, the concrete work to put specific pieces of data in, usually I let the applications pull that forward. Because otherwise, there's just too much work to do on data, and we don't know where to focus unless we're doing it for specific applications. And then over time, the data infra can get pretty good. Maybe just one more tip for enterprises. It turns out that if you buy SaaS software, almost every SaaS company will try to create a data silo in your company. But so when I'm selecting SaaS vendors, one of the things I try to do is own my own data infra, built on top of databases, obviously, but databases is easy to get data out of and put data into, so that's fine. And then I can get vendors to operate on my data layer rather than have all my data stuck on a data vendor that's hard to get out. Then that preserves a lot of optionality to look at my different pieces of data, connect the dots. I mean, so for example, I find that in some sectors, sales is affected by weather, right? Whether it's better or worse, you sell more or less.
Ice cream, for example.
Ice cream, right. And so your ability to pull out some info from a sales database and some info from some weather database and make that connection, there are so many connections like that that are really valuable to discover. But if all your data is stuck in some vendor silo, you can never make those connections. And I think AI is making it easier to make a lot more connections than before. So the value to owning or having access to your own data is actually much greater than it used to be 1 or 2 years ago. And we can't create all the software we want. You have to have vendors. But if you can have vendors operate on data that you still own and control, that's actually better than letting a vendor create another data silo in your own organization.
Well, amen to that. And this is an audience that really loves connecting data. So you're very much preaching to the choir here. I guess one more. Oh, sorry.
No, go ahead.
One more Neo4j related anecdote to what you just said is Klarna, who just went public on the New York Stock Exchange a few months ago, or maybe last month even. The CEO publicly tweeted about how they kicked out Salesforce and Workday and 1,200 other SaaS tools by building a platform on Neo4j and then layering AI on top of it, right? So a little bit related to what you just said with SaaS vendors.
Yeah, it sounds like that sounds like a real win. Food for thought.
Okay, so I want to switch to talk a little bit more about knowledge graphs, and specifically in the course that we created together, you and Andreas Colliger, you mentioned in the intro there, I'm going to read it here so I get it right, that knowledge graphs are an important way to improve RAG quality, and that they give more accurate information retrieval than vector search alone, especially for high-stakes applications where precision matters more than fuzzy similarity matching.
Yeah.
So in your experience, what is it about a knowledge graph that improves this accuracy and precision?
I think when nodes, entities, edges, relationships have clear semantics, you can very clearly look and say, is this person, an employee of that company, yes or no? And yes, we use an LLM to extract the information and put it into the knowledge graph, but the fact that you could do that ahead of time, verify it, and if it messes up sometimes, you can then fix it. That's better, or allows you to get higher accuracy than at runtime, dumping a bunch of documents and then letting it, hopefully do the right reasoning or the right inference or the right RAG style retrieval. So I find that for fast prototyping, RAG often works great, but after tuning RAG hyperparameters or whatever, RAG works great, right? I love RAG. But sometimes you can tune hyperparameters, filter this, filter that, but you're just not getting that, like at 90% accuracy. We just need this application to be like 98% accurate. And preemptively extracting precise knowledge, stick in a knowledge graph, and then let it know that, yes, this employee really is an employee of that, or this was shipped and this was the customer service ticker, whatever it is. Seeing a lot of the applications we build, that helps us really reliably get to a much higher level of accuracy.
Makes a lot of sense. And obviously what we see too, and especially if you add it up with what we previously discussed around spanning across silos. So if you then have a knowledge layer that crosses these silos together and have the same semantics, we've seen that work really well as well.
Yeah, kind of different graphs on different domains. You can then sort of connect it together.
And then connect it together. Exactly. Yeah. Cool. So just to wrap us up, a few personal questions. So you're doing a lot of different things, at the same time. How do you stay plugged in? How do you learn? I learn from the batch, for example, so thank you for that, right? What newsletter do you read, or what's your process for staying current and thinking and learning about the field?
Yeah, the batch is actually part of it. Our team does a lot of great work to identify top articles. And then I think I'm privileged to work with a lot of the leading AI companies, including you guys and Andreas, and those conversations to talk to. Because Cblend AI we're neutral, we're actually a re-vendor neutral organization that just wants to, teach good tools to everyone. That means that we get to talk to, like pretty much all the leading AI companies that often count on us to help with developer training. And it often gives us insights into the roadmaps, unpublished features, future plans of a lot of these businesses. So I think those conversations that I feel privileged to have. And I think here in Silicon Valley, between Cblend AI, AI Fund, Lam AI, some of my friends at Stanford, we have, communities that are very good at circulating knowledge. So I feel lucky to be able to talk to a lot of good people, and then hopefully to take that and as much as you can share it with everyone else as well.
So on a normal day, and I know that probably doesn't exist a normal day, but if you squint a little bit, how many hours per day do you spend learning versus teaching, meetings, that kind of stuff?
Don't know. I do take a lot of Cblend AI short courses myself. I try to watch a lot of them. And I don't know. I find that when I am interviewing an engineer, I'm often learning stuff. So that it turns out that sometimes a lot of good people are applying to work with us, and then during the interview they tell us what they do, and then I learn from that too. So I feel lucky that I go to lots of conversations, are able to learn stuff from all sorts of people. There's one thing I see in AI. There's so much new stuff. It feels like could have lots of random conversations with people and learn something new in pretty much every one of them.
What about your own personal daily AI workflow? What tools do you use on a daily basis?
Many of them.
Yeah.
LMs, I use multiple. Probably the obvious ones the most often. ChatGPT, Claude, Gemini. Highly agentic coding. I think I use Claude Code a lot, and in the last month, OpenAI Codex more and more as well. Made a lot of momentum, and still keep an eye on Gemini. I think I really appreciate the open source nature of that, and kind of I think there's real momentum there too. But it's one of these things, right? A lot of these tools, some of these tools barely, didn't exist even a few months ago. So if you ask me again in 3 months what I'm using, I actually don't know if the answers will be anywhere near the same.
Perfect. What a pleasure. Thank you so much for coming, and thank you for sharing.
Thank you.
Thank you. Fantastic.